Hi, in this video I will present a project developed at University of Warsaw together with Piotr, Marian and Jarosław. We prepared a brain-computer interface which uses reinforcement learning to optimize its operations. So what is a BCI? It is a device that connects human brain to the computer directly, which means that a human doesn't have to use muscles to, for example, type words or move cursor. We focused on a BCI which uses EEG signals. On the left, you can see example EEG recording setup used to play a game with a cap and electrodes on the head. On the right, you can see an example of multi-channel EEG time course. We created a simple game in which a person has to choose one out of 4 signs. For this, we use P300 paradigm. In a nutshell, first, the subject has to solve a simple equation and then observe only chosen sign, while the computer displays different stimuli in the form of short flashes. Based on the brain reaction to those flashes, BCI infers the category observed by the person. BCI made the correct decision, selecting different sign. What a surprise! In the last frame, I visualized the P300 potentials recorded during the experiment, so you can see that the observed division sign has a signal with a peak around 300 milliseconds after the flash. The ErrP setup consists of a person observing a screen with 4 mathematical signs and a simple ErrP agent controlling the BCI. The ErrP agent has to choose 1 out of 8 actions, 4 flashes of different signs, or 4 decisions corresponding to each category. If agent makes a decision, it ends the episode with the inferred human intention. Subject observed the flash on the screen. Whether he/she observed the sign, there may be or not a reaction in the EEG signal. To assess whether there is a response in EEG signal, we use an SVM classifier predicting if there is a specific reaction to the stimulus. Based on the written predictions, a state representation is created. It contains 4 probabilities of P300 occurrences, 1 for each sign, and 4 numbers of flashes of each category performed so far. Using this state, the agent performs next action. This cycle is repeated until the agent's decision. In an ErrP setup, we have to define a reward signal for the agent. We consider 2 scenarios. First one with a direct reward. So in our game, the environment knows what should be the correct answer in each episode. We can use it as a penalty for errors and delaying the decision, or as a reward for a correct decision. The second scenario uses feedback reward. When the BCI decision is shown, there is a human reaction to the error, which can be observed in EEG signal in the form of error-related potential, and then used to estimate reward. To test ErrP solution, we built a simulation system including, for example, environment model. What we found out is that ErrP agent can outperform BCIs based on a simpler policy. In the figure, you can see ErrP results in comparison to baseline policy of randomly flashing stimuli for a specified number of actions. We can see that ErrP agent can perform less actions and get higher accuracy, thus it improves in 2 important indicators describing BCI performance. Thank you.